Cool.
So we're going to talk about Nashorn. It's a script engine that comes with Java 8 and lets you run JavaScript on JVM. And we've been using it because we're working on some new applications here at Connect with React.js. And we want to try server rendering for various reasons, and we'll get to that in the slides, but oh, there you go, it's already there. Yeah, so JavaScript's awesome. I mean, it's a modern thing to do. You can't create rich, interactive web applications without JavaScript nowadays, really. And no, it's no longer just in the browser. It's crept out into everywhere else. So that's about it on that slide.
Yeah. And then we've got isomorphism, and the idea behind that is if you've got the same kind of entity running in two different contexts, such as on a browser and on the server, you want the same result on both. And that, of course, is like don't repeat yourself, because you just code it once, run it both on the browser and on the server. And that means less code, so it's easier to maintain, and then less testing, and therefore hopefully less bugs as well.
Okay, cool. So you've probably heard isomorphic and server rendering, and basically what it means is you run your JavaScript on the server and you produce HTML and you return that to the client. So contrary to what you traditionally do is you probably send like a tiny HTML payload with a script tag, then as soon as it hits the browser it would explode. So what we're trying to achieve here is get the HTML down first, so the first hit is quicker, just get some HTML and the page is straight there. The JavaScript will then bootstrap in the background, and then whenever anything happens, it will reuse that initial DOM payload, and then it will just carry on from there. So that's what we wanted to achieve with this.
So yeah, exactly what Arran was saying. You get a faster initial page load, especially when you've got like caching. So the cache will cache the pre-rendered server-side HTML. And also for SEO, I think Google's the only search engine that will actually execute JS and will crawl and spider the page after the JS is run, but I don't think other search engines will do yet. And also, if you're doing responsive design, where you're like targeting different devices and phones, tablets, desktop, laptops, etc., and different screen resolutions, if those details are passed in the user agent header to the server, then the server can then feed that into the JS engine and give you different initial HTML rendering based on like the screen size and what device or computer it is.
Yeah, cool.
So that gives you that flexibility as well.
The only thing I just want to add on that is I read a link the other day on like Google's crawling, and actually, even though SEO is important, Google's getting really, really good at crawling JavaScript on the server now. So someone set up like a React application with routing in there, rendering different components, images, just put it on his website. Once it got indexed, it basically indexed the whole lot, all the different routes that were executed through the JavaScript, the relevant components, content, everything. So they're getting really, really good at it now. So this may become less and less important for Google, but at least for everybody else, they're not even in the picture yet. So it still needs to be done. That's it. Yeah, cool.
Cool. Aha. So obviously this is the Java user group, so we want to do as much as possible with Java and the JVM. So I guess the only other option that we can think of for doing the server-side JS rendering is to perhaps like run a node server, but that would increase the complexity of the architecture and possibly even be a bit slower because the node would be running separate to the JVM. So it's like our preferred method of doing it is because we've got Nashorn in Java 8 and it's a JS engine that we can very nicely call from within Java. And we're going to come on to some code examples too of how you can actually call Java from within JS and vice versa. So it gets quite incestuous really, but pretty cool all the same. So we'll come on to that with some code examples shortly. But it looks like Nashorn is a really nice way of doing that in a Java environment. So here we go.
Cool. So this is just like a really simple example. It's actually, you could do it with 2 lines, but so you something called like a script engine manager, and then you can get the engine by the name of Nashorn. And then there's an eval method which is like overloaded with loads of different options. So you can just pass in a string. So there's JavaScript, create foo, and then print hello foo. You see it's calling print instead of console.log. That's because Nashorn's run on the server, so there's no consoles, no window, that kind of stuff isn't there. So we're using print in this example, but in production there's a polyfill that can just like polyfill that, so that when you can just write your JavaScript as you normally would, console log things out, and then it still works because you basically say console.log is print, and it just polyfills all that stuff in for you. The second example is just showing you can pull in a file. So this is just, you might have a large JS application that's got bundled down like with Webpack or Browserify or something, and then you can just point it at one file, and Nashorn will evaluate that the same way it did just standard string. Should we show the 3 examples in?
Yeah, should we do that?
Yeah, cool.
So this is an example of you're in a Java program and you want to pass a variable from your Java code into the JS. And so again, we instantiate the script engine, but now we're defining the function which takes the parameter name, and then it will append the name on the end of hello. And so what we do here, we've got an invocable of the Nashorn engine, so we can just call invoke function. So we call the function of name call me, and then the name parameter that we pass in is from Java. And so the system out at the end that's returned from that, it should give you hello from Java when that runs. So we'll come on to that example.
We'll run it and we won't like
in a minute. Yeah.
Cool.
And then we can do it the other way around as well. So again, do you want to?
Yeah,
because it's on 2 slides as well.
Yeah. So this one is similar. We've got call me, which is the same function that you saw on the previous slide. And then what you can do is you can just keep calling eval as much as you want, which is basically just execute some JS. So we're going to just make a new object in JavaScript and then put a key on there of greet, which is a function. So it takes a name, hello, whatever. Then we can access that object on the.
Should we go to the next slide?
Yeah, please.
Cool.
So then this line is like where the magic kind of happens, and you can do nashorn.get. So because object exists in the JS environment, it means we can just pull that out into Java. So now you've got a Java object that represents a JavaScript object, and you could then pass that off, pass it around your application, do what you need to do with it, and then you can just invoke it. So invoke method. So this is before we do an invoke function, which was just call a function in the JS environment. Is here we're saying invoke this key on this object in the JS, which was the kind of greeting function, and then name parameters after is just like passing world. So I think it would just say, I think it was printing hello and a var, so that would be like hello world. But these examples just show the awesomeness of like the two, like being really, really interlinked. So when I first started looking at Nashorn, I thought it's just you pass some JavaScript and it does something with it. But I think when we started digging into it, really realised, well, you can actually pass things back and forth, share things between, and then your kind of scope for applications becomes massive. So some of this heavy lifting you might do in JavaScript, now you can say, well, let's not make those network requests in JavaScript, let's pass them in from Java. We might already have that data in Java, so we cut a network hop down, reduce your complexity in your JavaScript. Is there anything else you want to add?
Might as well just run the test applications. So let's see the simple example. I've commented out the read the bundle.js because we haven't actually got that to hand. So if I just run that as a Java app, then it's just appending the world onto the hello, and you get hello world.
Like one thing you can see from this is it's pretty quick too. I mean, it's not instant 'cause it's got to do a little bit of something, but once it's got up and going, it's really quick.
Yeah, because it's like if you've got like a lot of JS files, it can take a while to initially parse them and evaluate them, turn them into bytecode.
Yeah.
But once it's done that, then subsequent executions can be really quick.
Definitely. I saw a graph. I should have put it in the slides. I completely forgot to. It was showing like execution time versus Node. And at the beginning, Nashorn was quite slow compared to Node. Once the hotspot kicked in and JVM got going like it normally does, it was just down, and basically Node and Nashorn were equal in terms of speed. So there's a little bit of a start-up, but after that they're somewhat similar in performance, which I thought was, considering V8's been around quite a long time and it's quite polished, I was surprised that it is as quick, almost.
So the next example we're going to go through is pass Java to JS. So if I run that, that says hello from Java. So that's where we've got the call me function that takes the name and it appends that onto the end of hello. And then finally, the more complex one where we invoke the JS from Java with the greet. So again, that just comes out with hello world at the end.
Cool. Yeah, so it works.
Cool. Yeah. And we've also got something called JJS. Now, as Dippin, that was good because Dippin was speaking about the REPL. So I could type JJS and I might say something like var test equals testing 1, 2, 3. And then we've got print, haven't we?
Yeah.
Test plus 4, 5, 6. Oh.
Oh, you put in brackets.
Ah, of course.
Sorry, Ruth, can you zoom in a bit? I'm not curious. I can't see it right here. Zoom off.
How do I do that? Zoom in.
Command and plus, I think.
Command plus. Oh, brilliant. Perfect.
That's it.
Much better. So yeah, it does. So it's set up the var called test that's testing 1, 2, 3, and then we can just do the print where we're appending the 4, 5, 6 to it as well.
Yeah.
Very simple Mickey
So,
Mouse test.
as well as the kind of inline command by command, you can also just pass a JavaScript file into it. I think I've put one in here.
Yeah, if I quit, how do I quit out of that? Oh, I've done it,
Got it.
great. So you can do JJS example.js,
Yeah.
and if I show you what example.js is doing, that is
Yeah, so I just put something really simple.
Yeah.
I just wanted to show that it's like, it seems daft, but sometimes it's like, can it actually do all the JavaScript, or is it just do some of the JavaScript?
Mhm.
I just put, you can just write anything in there, like standard functional stuff. Map over a list, times them by 2, and then reduce them into a string, print it out, and that works just fine. That's all there is to say on the REPL really. It's just like standard Node kind of environment that you normally have.
mhm.
Cool.
Cool. I'll just run it again. And yeah, it's just multiplying the numbers by 2 and stuff. Quite similar to like Dippin's example before, really, but in JS. And then, of course, we've been talking about Nashorn, but a bit more information about what it is. So it just runs JavaScript natively on the JVM. You get it as part of Java 8 out of the box. And compared to the Rhino.js engine that I was using like back in 2002, it's got much better performance. And like we've shown, you can do command line execution using JJS, which you can also use like a REPL, and then you can execute JS from Java and vice versa as well. So it's very flexible and powerful, letting you do that. And also, currently it supports ECMAScript 5.1. We're not going to get ES6 until Java 9 by the sound of it, but we just use the Babel polyfill, which transpiles ES6 down to 5.1. And we've got Webpack as well with Babel.
Yeah. So that's how we get around it. Same with like browser problems. You can't run the latest JavaScript in the browser today, so we use Babel to squash it down into like 5 spec JavaScript. The problem with this stuff is you're always going to be behind. Like browsers going to be behind. This is going to be behind. By the time Java 9 comes out, it's already going to be the next version. So I don't see the use of Babel ever going away. It seems like you get the features today.
Mm-hmm. It's always like one step ahead of the curve, isn't it, Babel?
Yeah.
Whereas this is like almost like a step behind, really.
It is, and if there's as soon as there's something in the spec, like Babel seems to have it yesterday.
Yeah.
I don't know how, but it's pretty good. Let's see what I think on that.
Oh yeah, this is something that we found was really critical when we were doing our investigation, because what we were trying to do was we were trying to use React within and Redux as well, but we were adapting some client-side code that went off using promises. So it was like making a JSON call, and then there was a promise that was called back when you got the stuff back from the server. But we found that it didn't like that kind of paradigm of programming at all, because basically as soon as it had made the call to the server, it just bombed out and didn't actually return anything.
Yeah.
So we had to rewrite that so it did it in a different way. So it didn't use promises. So anything that's like using events or callbacks doesn't look to work very well with Nashorn, if at all.
Yeah.
I think some people have tried to kind of like hack it by doing things with like threads and futures and stuff, but it looked a bit messy.
So I think the main difference probably with this stuff is that JavaScript's single-threaded and Java's multi-threaded. So if you look at the JavaScript spec, it's all about how does this operate in a single thread. You don't have to worry about concurrent issues. So I was reading an article last night in preparation for this about how Oracle approached this, and one approach, which was obviously crazy, is how do we make JavaScript multi-threaded? And they thought, well, everything's going to have a lock. Everything's going to have to be protected in some way or another. And now all of a sudden you've lost all your advantages of being a single-threaded system, and you lose all your performance. So it's a bit horrendous. So instead they basically offer some best practices on how to approach it so that you don't get yourself into too much of a mess. And they're on the next slide.
Cool. So, yeah, obviously if you've got a script engine that you want to reuse, the best thing to do is to put that in a thread local, because Java 8 gives you a thread local, so you've got a unique instance of that script engine in each thread. And then obviously avoid sharing script objects themselves, so it's better to use primitives or Java objects and then convert them to JSON and vice versa.
Yeah, that's one way to get around it, is if you've got a JS object and you need to share it somewhere that's going to be kind of in a multi-threaded scenario, so you just hack it together, like turn it into a string, it's a primitive type, pass it around, parse it back on the other side. It's a bit of a hack, but it's what Oracle said to do, so I guess it's good. But in our case, we've got around a lot of this issue for just using like a thread local. Seems to be the way to go. So a lot of I guess it depends as well, because if you're doing stuff that's not going to be crossing over itself, you probably be okay just to have like a singleton of your kind of script engine and just use it as you would anything else. It's only because we're running like a large web application where each request is going to want something different, and then you're going to get into a mess. So thread local fixes that up, and seems like a perfect example of how to do it. We'll show you an example in the code in a minute of like how all this hangs together.
Yeah. So we're going to look at the example using React. There's no Redux in this. I think originally we were hoping to get Redux in it as well, but it just made it a bit more messy, and it kind of took away from the Java a bit more, I think, didn't it?
Yeah, I think it got a bit verbose.
It got a bit verbose, yeah.
Yeah.
So
do you want me to point at stuff?
Yeah, cool. That'd be good. So
okay.
We've got like a really simple controller that's setting up a list of Star Wars films. So it's got the title of the film and the date that it was released. And the request mapping for this is at /react, and that's just taking the servlet request and then it's putting stuff on the model. So it's putting the request path from the URL and then the list of films, and then the view is actually going to react.ejs, and EJS is a templating language for JavaScript. So
before you change Ruth,
yeah.
I just thought I'd say is this top line where you actually, can you read that? Is that okay?
I can try increasing there's Control Plus work on this as well. Command Plus.
I don't know.
No, it doesn't.
Okay.
No.
So I'm just adding an attribute onto the model, which is the request path. So this is important because when you're building, like, if you're building a kind of a large JavaScript application, you're probably going to have some kind of routing in there that draws different components depending on where you end up. So this is kind of how you can pass your request mapping from Java into JavaScript. So you get your URL, so this is just going to be like, you know, whatever /react, and it might have some other stuff on it if you built up a bit of a string. So eventually we're going to pass these objects from the model into the JavaScript. And then when we bootstrap our application, we can say this is our route, propagate that to the router. Typically in a browser that would come from just the URL. Obviously we haven't got a URL because it's kind of gone through all the servers and stuff, but you get to the same place, but if you have routing in your application, you're going to definitely need to do something like this. Cool, okay. Move.
Yeah. I'm just going to look at the view config very briefly, and this is where we set up the configuration for Spring. And so, like you were saying about the polyfill, we're passing the polyfill.js to Nashorn, and then EJS library for the templating, and then render.js, which we'll come on to, which is where it pulls the data out of the Spring model and puts it in a format it can pass into the JS. And then bundle.js is what Webpack's bundled up of the React app.
Yes, that's basically, the bundle is our application that we built. So what we actually do is, as part of our Maven build, is we kick off Webpack, build our application into one JS file, move it into somewhere sensible, and then we can access it from Java. Because we don't compile the JS on the fly, like we use Babel, transpile it once, then it's done. Saw some people trying to do it on the fly. Seems a bit mad, but yeah, that's the way we do it.
Yeah, and so the view resolver is just saying to look for all the JS under the templates directory, and then all this stuff will just be within the templates directory, and then it's basically script template configurer does all the sort of thread local stuff for the Nashorn engine. So it's creating the Nashorn engine, passing the scripts through, and setting the name of the render function that we were talking about to render.
Yeah, so
and then if you set shared engine to false, that makes it thread local, and then it just returns that configuration to Spring. And the film object is just a bean for the title and the year for the film. And so coming onto the JS side of things, so polyfill is just polyfilling things like global and the console and stuff like we were saying. So anything that's console.print whatever log, that just goes to print. And then it's also polyfilling object.assign, because that you don't get that out of the box with Nashorn either, so you've got to polyfill that as well. Then render.js.
Yeah, so this is the kind of the bridge between Java and the template, which is basically the JavaScript starts to take off, I guess. So we're creating just a Java object up here, which is like the Jackson XML mapper. And we're using that because we're passing these film objects, which Ruth just showed you, and we want to pass them into JS. So you can just pass JavaScript objects straight in, but it's cool. We just turn them into like a JSON format and then pass them in that way. So it's like really simple. So this function will get returned and then kind of self-executed. So the request path and pulling it out of the model, that's what I put in there in the controller, and the same for the film list. So what I'm just doing here is parsing the JSON that comes out of the serializer. So that will now turn that into a JavaScript array with JavaScript objects in it with like the key for like name and the year and that kind of stuff. Then we create a new EJS and pass in our template, and then kind of just let it do its thing.
So what EJS does, I mean, this just looks like bog standard HTML, apart from this bit here, where it's got the same sort of syntax as you just like have for a scriptlet in a JSP.
Yeah.
So it's calling react-app.render, passing in the request path from Spring and the film list from Spring from the model.
So those two values there are two values that I just created in the render file, the same keys. And the React app, this is the only place where it's like slightly confusing. In fact, the render function is, we also saw that, we passed that as a string into the script engine template. React app is in the JavaScript kind of life, we expose our application through bundle.js. But how do we access that? Because there's lots of stuff, so you need a name. And we do that in our Webpack config. So if you could click on Webpack config.
Yeah, then the library attribute is saying we're going to expose it as React app. Because then if you come onto index.js, it's just it's exporting the function called render. So therefore, if the library is React app, you can just call React app.render then. And then that is calling the React render to string method for the app that's expecting the film list. And if you go onto app.js, then that is just going to create us a div that says hello from React, and then it's going to add the film list, and the film list is so we're mapping each film to output the key and then the film itself.
So this is
and that's got the title and the year.
Yeah, so this is React app. React code. If you haven't used React, it probably shouldn't all be one file. It looks like a horrendous line, but at least it's in here.
We've done it like this for brevity, haven't we? So we haven't got like
Absolutely.
a gazillion files just because it's a quick demo.
There's already a lot of files that you've probably seen. It's like a big jigsaw. It wasn't straightforward to get all these bits talking. Once you kind of learn how everything's working, it kind of makes sense. But I was looking at examples online when we first started, and it was kind of like, okay, so where do we start with all this? But it works quite well now. So yeah, so this at this point, film list will be our like serialized with Jackson list that we did in the render. So we can just do, at this point, it's just standard JavaScript. It's got nothing to do with Nashorn or Java. It doesn't care. Do you want to hit the browser?
I'll fire it up, yeah. So I just go to localhost 8080/React, and there we go. Hello from React, and you've got the list of Star Wars films.
The only Star Wars films.
And then view source, and it's got a load of like React stuff as well, because React always puts IDs on for its stuff internally, so it knows what it's doing with it.
So one thing which I will show is if you do an inspect on the page, Ruth.
So if I inspect on the page, such as on here.
Anywhere you want.
Yeah.
And then open the network.
So the network has got that, yeah, okay.
And then refresh page. Oh, I think it's over there. Is it cut off?
What's cut off, sorry?
The network request. You should be able to click on it. Oh, I think it's on, I think it's yeah, pull this down.
I've got you, sorry,
Yeah.
this bit here. Oh yeah, there we go.
So if you click on the React line, and then response.
Response, yeah.
Up here.
I've got you, yeah.
So this is what came out of the server. So you can see, if you scroll, it is our HTML. It wasn't just a big ruse and we just put the JavaScript on the page and let it happen. So you can see that is the HTML coming out of the server.
These are the films you were looking for. No, we won't do that.
We could have achieved the exact same thing by just, you would not tell any difference from the client. And one thing that React does is, if you return from the server something that's slightly different to what the browser would have generated, it just throws away the server copy and it will plain in the console. And the reason for this is just to make sure that you're kind of keeping everything correct. So what happens is the HTML comes down from the server. It then executes what it would do. It would it would happen. Sorry, it would run real quick on the browser, and then it would just compare the two to make sure they're correct.
Mm-hmm.
So that's basically it.
Because it normally like makes a JSON call back to the server to get the JSON back that it would normally use to render it.
Yeah, precisely.
But then if you're sort of like clicking things on the page and things are happening, then any subsequent updates to the page are done. So like in on the client side, so the client makes a server call to return JSON, and then the JSON then feeds back into React and updates the page, just that bit of the page dynamically.
Have we got any slides left? I think we're out of time.
Yeah, I think there's just a further resources link to that boilerplate project of yours.
Yeah, so there's a boilerplate which has got basically the template for all this and how it's all connected. So I'll share the link around in the group so everyone can have a look. Any questions? No? Brett, ask a question.
Server, Arran.
No questions then.
Cool.
Just one like that. So JJS, I was quite interested in that. Does that require any extra setup, or is it just in the bin directory which anyway?
Just install Java 8. You had a problem with
I had to
path.
create a symbolic link from
Yeah.
from /usr/local/bin to
Mine just worked,
yeah.
but I think I installed Java 8 straight from fresh. Whereas
Yeah.
you probably went up from Java 7. So
What version's your Mac on? Because mine's not on El Capitan yet. I don't
no, I think it's the latest.
That's probably why. It could be because I'm still on
It is just
Yosemite.
Standard
Yeah.
with Java 8 JDK.
Cool.
Right.
Great.
Thank you. Cool.